Okay, let's do sentences with two quantifiers. So the sentence that we're going to analyze is every actor knows some skill. So we have two quantified noun phrases, every actor, some skill, which means that we can move them in two orders. Either we can move every actor from the subject up into the highest position and move the direct object into the lowest position. So in this case, we have all x scoping over exists y. Or we can do the reverse direction, where first we move every actor up into the lower position, and then we move the object some skill up into the higher position, so that way the existential is scoping over the universal. Now, for the sake of space, what I've done is I've done the initial tree up to S1. So specifically, this sentence here is just T1 knows T2, and then we'll do the binding after. So we have a trace here. We have the trace T2. I'm going to try to keep, what were the colors on the previous one? T2 is red and T1 is blue. Okay, let's keep this the same. Okay, so T2 is going to be G of T2. This is just our assignment function. We don't know what this is yet. If it's free, we'll check the assignment function later to figure out what it is, but it could be bound at some point, so we don't want to evaluate it right away. Okay, this goes up to the noun phrase, so it has the same meaning, G of T2. What do we have here? We have our verb knows. So knows is transitive. Instead of xy, so that x knows y. So this is normal. And then for our VP, we're doing the transitive merging to get the meaning of the VP. So we're going to end up with the set of x such that x knows g of t2 in M. So exactly the same as we've done it before. Now we have a subject, t1. So we need to ask ourselves, well, what is the meaning of t1? Well, it's just the assignment function g on t1. So we end up with the same thing moving up. And now our sentence is true if the noun phrase is an element of the set of the verb phrase. If the lexical entry, sorry, the semantic value of the noun phrase is an element of the semantic value of the verb phrase. So specifically, if g of t1 is in the set of x such that x knows g of t2 and M. So this is the same thing if you were to say, I don't know, Emily knows Jacob. Okay, if the words were Emily knows Jacob, then this would be true if Emily was in the set of x, just that x knows Jacob and M. It's just that we don't know what the traces are. That's why we have G of T1 and G of T2 there instead of words like Emily and Jacob. It is the same process. So don't be too scared about these G's and these T's. They're no different than proper names. It's just we just don't know what they are yet. So now that we have the base, we're going to do the two different interpretations. So we're going to do the interpretation where for all x scopes over exists a y. So this is where we have t1 up front and then exists a y t2 at the end. So to zoom in on this, here's t1 knows t2. I've kept this in from the previous slide. So if g of t1 knows g of t2 in M. Okay, so first we have, what is it? A skill, some skill. So we can give meanings to skill in the common noun. So x is a skill in M, and this goes up. And we notice that this NP2. So this corresponds with trace 2. So our direct object has moved up into this position. So now that we have some skill, and we have g of t2, we can do a substitution here. So we know that this sentence is true if for some d in our universe, d is in the set of skills, so d is a skill, and S1, where t2 now points to d is true. So sentence 1 with that assignment function replacement is true. So what we see here is that when we spell this out, we're saying if for some d in our universe, if d is in the set of x, such that x is a skill in M, or sorry, I shouldn't say if. So for some d in our universe, d is in the set of skills. So d is in the set of x, such that x is a skill in M. And we use and because we have the existential, of course. Then we say g of t1. So our subject is still the same. We haven't made any replacements yet, but we have made a replacement on D. So we know that T2 now corresponds to D after making this assignment function replacement. So now D is in our universe, D is a skill, And G of T1, whatever that trace is, now knows a skill which happens to be D in M. So if we think about how this is binding right now, we really have exists a y here. So I should use the y component here to be consistent with what we've been talking about. I'm trying to figure out how I want to write this. So we can say there exists a y such that y is a skill and knows xy. So we know what y is at the moment. We don't know what x is, so x still hasn't been bound yet. But that's our next step. Our next step is to do the binding on x. So that's why we still see x as g of t1, because we haven't bound it yet, but now suddenly our g of t2 is bound, so this becomes d. Okay, let's take a look at the next step. And again, this might look scary, but again, it's just an application of the rules. So actor, every actor. Okay, so x such that x is an actor in M, that goes up to the tree. So our common noun here is actor. So at this point, we've already used D, so we're not going to use D again. We're going to instead use D prime. We could use a different letter like E or F or whatever if we wanted to. So now we're saying if for all D prime in our universe, if D prime is an actor, then S2, so this is S2, where D prime replaces T1 is true. So now we're making a second adjustment. Now we're saying that all of our T1s are going to be D primes, and we need to check every D prime in our universe, and if D prime is an actor, then that sentence exists a Y skill Y and knows XY. That G of T1, that X and knows, should now point to D prime, that new thing. So the second step is just here to illustrate the process in more detail. I'm going to skip straight to the third step. Now we're saying it's true if for all D prime in our universe, if D prime is an actor, then for some D in our universe, and here we're just spelling everything out in S2, so some D in our universe, if D is a skill, shouldn't say if D is a skill, then for some D in our universe, D is a skill and D prime is in the set of X such that X knows D in M. Now if we take a look at the colors here, and again, this does get a little bit messy just because there's so much on the screen. So let me just clear some of the stuff up that we don't need here. The differences between our two now is now G of T1 has been bound by D prime. So G of T1 has become D prime after binding. D remains the same because it's still bound. But at this point, we've done our binding. So at this point, we've done R for all X. Movie X, arrow, exists a Y, skill Y, and knows XY. So at this point, we have now bound it with for all X, which is why we no longer have G of T1. Now we have this other variable D prime that it is pointed to. So as you can imagine, this is not necessarily an easy thing to explain with intuition. It is very much in the realm of predicate logic. It's motivated a lot by that, so the more familiar you are with predicate logic translations, I think the easier this is to grasp. It doesn't mean it's easy to grasp, it just means it will be easier to grasp. More repeated applications of the rules. So I've tried to sort of motivate why these changes occur and how it's illustrated with colors. But still, it does take some time to look at the tree and work with the tree and practice with the trees. So I guess another thing I want to say here is this line right here, where we have G, and we have this change where D prime replaces T1, and D replaces T2. So this middle line, what I've done here is I've shown both of the conversions. I've shown the conversion where we replace T2 with D, and where we replace D prime with T1. And that's because these are bound by different things. So T1 is the NP1 binding, and T2 is the NP2 binding. So in our tree, when we're reading from top to bottom, this one occurs first. D prime binds first. It's the highest bound thing. It's the quantifier with a wide scope. And then this binds second, d over t2. So that's why we have d of t1 in the inner brackets and dt2 in the outermost brackets. Anyways, let's take a look at the other example and contrast it with this one. So it's going to be the same thing, except the order in which everything is bound is going to be different. So instead of saying if for all d prime and u, if d prime is an actor, then for some d, d is a skill, and d prime is in the set of x's that x knows d, the if d prime and then some d are going to be swapped because the quantifiers are in a different way. In fact, I've actually used different variables for this. So we still have T1 knows T2, so if g of T1 is in the set of x's that x knows G2 and M, that's going to be the same. Actor is going to be the same here, but now we have every actor down below. So first we're going to have our blues here. So at this point in our translation, we have knows. So that's going to be x, that's going to be y. But what we're doing now is we're binding actor first. So we're doing for all x, actor x, then knows x, y. So we're actually doing the blue binding first with our variables. So that's what we see here. We see if for all d in our universe, if d is an actor, then S1, where T1 is replaced by d, is true. So now because 1 is our actor, we're replacing 1 with d. So if for all d in our universe, if d is an actor, then d is in the set of x just that x knows g of t2 and m. So we haven't bound y yet, so we haven't done that replacement. But we have bound our subject. We have bound t1, so that's why we've done a replacement from g of t1 to d there. And when we go to the next step, same process occurs. So this is our NP2. We have some skill, so x is a skill in M. So how we read this now is for some d prime in the universe, d prime is a skill, and S2, where we do a replacement where T2 now points to d prime, that's true. Now we can spell this out a little bit more in the second step, but third step is where we get our final meaning. If for some d prime in our universe, d prime is a skill, and for all d in our universe, if d is an actor, then d knows d prime. So now we have bound d prime. We have now bound g of t2. We've made that replacement. So we can now substitute it in. And we're essentially just filling out the rest of the predicate logic translation. So now we're doing, okay, there exists a y such that y is a skill. And for all x, if x is an actor, then x knows y. So that's exactly what this bit corresponds to at the top. So there exists a y, there is some d prime in u, such that skill y, such that d prime is a skill. And then for all d in our universe, if d is an actor, then d knows d prime, and d prime corresponds to that direct object. So again, I repeat this many times. It looks intimidating, but this is really just a step-by-step process, which is why I have a few examples that you can try on your own, as well as looking through these examples again. But I believe that's it. Yes, that's it for our two quantifier trees. If you have any questions, as always, discussion board or email, and I'll get back to you when I can.